A 5 kg block is connected to a 3 kg block by a light instable string through a frictionless pulley as shown in the diagram below. A force F of magnitude 80 Newton force is applied on the 5 kg block at an angle of 30 degrees to the horizontal, and the system accelerates to the left. So we can do this. We can show the arrow here to show that the system is accelerating to the left. So its acceleration it accelerates to the left at 2.2 meters per second squared. So this is the acceleration, 2.2 meters per second squared on a rough horizontal surface. So now 2.1, it says you draw the label free body diagram indicating all the horizontal. So be careful, check, they use caps, capital letters. It means very important. So you indicate all the horizontal forces acting on the 5 kg block, only horizontal forces. So check is 3 marks. So it means that we must only show 3 forces, or these are the 3 forces or 3 horizontal forces acting on that object. So let's start. So this question is question 2 in grade 12, and then in grade 11 is question 3, something like that. So 2.1, we must draw the free body diagram, right, showing all the only horizontal forces. So a free body diagram, we use a dot. So we can use a very big dot. Make sure that the dot, it accommodates all the forces. So now let's check. The system is accelerating to the left. Already we see the tension on the rope or on the string. So we see the tension. So this is the tension. So since they said it is on a rough horizontal surface, it means that there is a frictional force. So we can show the frictional force opposing the motion. Make sure it's a small letter F. That was my mistake. Make sure it's a small letter F. So remember, this one, it opposes the motion. So since the object is going to the left, it means that frictional force going to the right. It opposes the motion of an object. So now this force is acting at an angle. So since it's acting at an angle like this, going down at an angle, it means that we have this force, or the components of this force, which is Fy going down, and then Fx going to the left. So this is Fx. So this is Fx. This is the horizontal component of this force, since it has the components. So this is the horizontal component of this force. So these are the 3 forces acting on the object. So the mark allocation will be this way. You have 1, 2, 3. So this is your 3 marks, right? Okay. So 2.2. You calculate the magnitude of the tension in the string. The magnitude of the tension in the string. So to simplify life, let's say we are going to use 3 kg block. It will be easy for us to get the tension. Let's focus on the 3 kg block. Why? Because 3 kg block, it only has 2 forces acting on it. So this is our 3 kg block, the free body diagram, and then we have the tension. This is the tension going up, and then the weight, or the frictional force, the gravitational force. So since block 5 is going to the left, it means that the 3 kg block is going up. So tension is bigger than weight now. So now we're going to say F net as the Newton's second law is equals to MA. Let's make sure we start here so that we can avoid misconceptions and misunderstanding of this stuff. So now what is our F net? Since we have two forces here, it means that we have the tension. This is the tension is the one pulling the box up, minus weight is equals to MA. So since the question said we must calculate the tension on the string, so T minus, what is weight? Weight is mg. Then what is m? M is 3 kg. G is 9.8. So here we're going to have 3 times 9.8 is equals to the mass, which is 3. And then acceleration, we're given acceleration as 2.2 meters per second squared. So this 2.2 meters per second squared. So now T, this T minus 3 times 9.8, we're going to have 29.4. Then is equals to 3 times 2.2. This is 6.6. So T is equals to 6.6. This one to the other side is going to be plus 29.4. So when we add this up, it's going to give us 36 Newton. So this is the tension on the string. And then 2.2, this one's 2.2.1, then 2.2.2. Let's just jump to this side. Divide. 2.2.2.2.2. Now we must calculate the coefficient of kinetic friction acting on the 5 kg block. So now we can focus on the 5 kg block. 5 kg block. So on the 5 kg block, life is easy because already we drew the free body diagram showing all the horizontal forces. So it means that on the 5 kg block, we start here, F net is equals to MA. Now let's go back. Let's check. This is the free body diagram on the 5 kg block, right? So what do we have here? We have Fx going to the left, and the block is going to the left. It means that Fx here is our bigger force, minus tension is opposing, minus frictional force is also opposing, then it's equals to MA. But before we go far, we are not given the frictional force here. That means we must do something to find, or since the question said we must calculate the coefficient of kinetic friction. So according to the frictional force Fk, the coefficient of kinetic friction multiplied by normal force. So we are looking for this, right? And we don't have the normal force. It means that now we must calculate the normal force. To simplify life, we must calculate the normal force. So to calculate the normal force, remember, the force is acting at an angle. So let me draw the free body diagram again here. So we have the tension going to that direction and the friction going to that direction, and then Fx, this is our Fx, and then there is weight going down, also Fy going down, and the normal force perpendicular to the surface. So now what is our normal force? This is how we can find the normal force now. So normal force, the force that is going up is equal to the forces that are going down. That is our F net. So we have Fy plus weight. Right. So now what is our Fy? The force the force is given as 80 Newton, right? So Fy is the vertical component. So this is 80 as the vertical component. Remember, let's just remind each other, Fy is equals to F sine theta. Fx is equals to F cos theta. So we're talking about Fy here. Fy is F cos theta. So this is our F, or no, sine theta for Fy. Then sine, what is the angle? So they said the angle is 30. So that means it's going to be sine of 30 plus, what is W? W is our weight as mg. So what is m? M is 5 kg times 9.8. Right. So this is what we're going to need that side for the normal force. So now we're going to say Fx minus the tension minus, here we're going to say this is the coefficient of kinetic friction multiplied by normal force, then it's equals to ma. So now Fx, oh sorry, let's just substitute. So what is our Fx? Since Fx is F cos theta, so F as 80 cos 30, the given angle, minus, already we calculated the tension as 36, so we just put 36 minus, then here we have the coefficient of kinetic friction, then let's say we multiply. Okay, we can also use the bracket, no problem. So now we have 80 sine 30, so this is 80 sine 30 plus 5 times 9.8, 5 times 9.8, then we close the bracket, then it's equals to 5 times the acceleration is 2,2. So from here we can just punch the calculator here. 80 cos 30 minus 36, so it's going to give us 33,282 minus, so when we punch the calculator here, 80 sine 30 plus 5 times 9.8, so the answer is going to be 89. So multiply by this one, so the coefficient of kinetic friction. So this 89 coefficient of kinetic friction, then it's equals to 5 times 2,2, this is 11. So now we take this 33,282 to the other side. So we're going to have negative 89. The coefficient of kinetic friction is equals to 11 minus 33,282. So negative 89 coefficient of kinetic. So 11 minus 33, that one is going to be negative 22,282. So now we just divide by negative 89 both sides. So the coefficient of kinetic friction is equals to, so remember the coefficient, it doesn't have units because the ratio of two forces. So the answer is 0,25 with no unit. So now what is the next question? Now the next question says, how will each of the following be affected if the angle between the surface and the force increases? So before we choose the answer, since they're saying the angle between the surface and the force increases, so once we increase the angle between the force and the surface, the normal force itself, it will increase. So it means that we're increasing the normal force. Once we increase the normal force, according to the formula Fk is equals to the coefficient of kinetic friction multiplied by normal force. So once we increase the angle between the force and the surface, the normal force, it will increase. And check the formula. Normal force here is directly proportional to the kinetic frictional force. Normal force is directly proportional to the frictional force. It means that when we increase the normal force, the frictional force it will increase, right? So now the question says, choose from increase, decrease, or remain the same. Give the reason for your answer. So they're talking about the frictional force here. Since we're increasing the angle, normal force it will increase. Once the normal force increases, what's going to happen to the kinetic frictional force? The kinetic frictional force it will increase because they're directly proportional to each other. So now we're going to say the answer is 2.3.2. So 0.1. So the answer is increase for kinetic frictional force. So we're going to say the answer it will increase. Then they said we must give a reason. So the reason is, since we increased the angle, normal force increased. That means frictional force increased. So the reason is normal force is directly proportional to the frictional force, or to the kinetic frictional force. Right, so here is a 1 mark for saying it will increase, and then here is the 1 mark for the reason. Now 2.3.2, they want to know what's going to happen to the coefficient of kinetic friction. So what we know about the coefficient of kinetic friction is the coefficient of kinetic friction, it depends on the nature of the surface. So the nature of the surface, we're talking about the rough horizontal surface or the smooth surface, but that is the nature of the surface. So it means that the angle has no effect on the coefficient of kinetic friction. Since the angle has no effect on the coefficient of kinetic friction, it means that 2.3.2, this one, it will remain the same because the angle has no effect on the coefficient of kinetic friction. So now, what is the reason? The reason is the coefficient of kinetic friction depends on the nature of the surface. So the coefficient of kinetic friction, it depends on the nature of kinetic of the nature of the surface only. Let's say only. Yes. So the coefficient of kinetic friction depend on the nature of the surface only. So that is the reason for this answer. It means that also that one is 2 marks. So you will have 1 mark for saying it will remain the same and 1 mark for the reason.